All right, so we'll look at number 11 first. This is from, again, the 1.3 homework over order of operations, number 11. If you have not done number 11, you need to make number 11 the very next problem on your work paper. Okay, just put it right after wherever one you're on, because if we're looking at it, there's no point for you not to write it down. That doesn't make any sense. So it says 4 squared times 2 plus 8 times 7. So Gage, we'll start with you in the back there. What's the first step order of operations would tell me to do for this problem? That's right. That's right. And what does 4 squared mean? 4 times 4. That's right. Not 4 times 2. That would give us 8, and that's wrong. Gage, what is 4 times 4? 16. Excellent. So I'm going to write down the problem on my work paper, the original problem. So I got the top part of my funnel. And then underneath of that, I'll write down 16 times 2 plus 8 times 7. All right. Andrea, what comes after the exponents here? What should I focus on now? It would be, you're right, multiplication, division, and we see the multiplication up here. And we're supposed to start left to right. So why don't we look at that left side? We've got 16 times 2 is the very first one I see. So Andrea, what do you get for 16 times 2? What do you think that would be? It is, yeah. I was gonna say this might be one that we, since we don't know our 2's all up to 16, it could be one that we just write down. Yeah, we're gonna get 32 for that. So that's gonna give us 32 plus, and then I could write 8 times 7, and you'd be fine for doing that, but that's obviously the next one I'm going to do, because I'm working from right to, or from left to right there. So let's go up to Maddox. Maddox, what do you have for 8 times 7? Or what would you have? 56. Excellent. So we really did 2 steps in one, but it was the same multiplication step, just working left to right. So now we have 32 plus 56. Obviously, adding is our last step. Remember, we talked about level 4 priority, adding and subtracting. And so we'll go ahead and add and subtract these, or sorry, not add and subtract, just add these here. And I'm going to go off to the side to do this as well. 32 plus 56. Whitney, what do you have for 32 plus 56? That is right. Our answer for number 11 should be 88. And again, it's supposed to funnel down. My funnel's not super good because the first line they wrote, I didn't write it myself. Okay. Now, Natalie, you would also ask about number 12. Okay, so number 12 actually uses all but one. No, actually, it uses all of them. I see every single operation in here. Now, normally subtraction along with addition would be the very bottom level of order of operations. You know, please excuse my dear Aunt Sally, parentheses, exponents, multiply and divide left to right, add and subtract left to right. However, the parentheses here make the subtraction the very first thing I'm going to do. They make it a level 1 priority. So, Hunter, what do you have for 6 minus 3? 3. Yeah, let's get this out of the way. Okay, so we're going to do 3 squared plus 12 divided by 3. We don't need to write the parentheses anymore because there's no operation in there. We know 6 minus 3 is 3. After parentheses, Avion comes what? PEMDAS. PEM. I know. This is, I'm trying to remind him from last year. PEMDAS. Please excuse my dear Aunt Sally. Please, parentheses. Evacuate. Not evacuate. Something we talked about earlier this week. You just turned the homework in for it at those little tiny numbers. Exponents. That's right. Exponents. And so we're going to focus here on the 3 squared. Now, 3 squared does not mean 3 times 2. We know that means 3 times itself. What is 3 times itself? 9. That's right. So now we have 9 plus 12 divided by 3 times 8. All right. Natalie, I've got division and multiplication. Which of those do I do first? Because obviously addition's last. We do the division first, exactly, because it's farther on the left. We go left to right here. We don't do the multiplication first. That'll give us the wrong answer. So Natalie, what do you have for 12 divided by 3? 4. Okay. Now we can do the multiplication. Aaron, what do you have for 4 times 8? Yep, 4 times 8. 32. Okay. And then our last step here is going to be the addition. So Joe, what about 9 plus 32? 41. And we funneled all that all the way down. That was probably the longest one, I think, that was on here, if not one of the longer ones. And you don't have to, again, you don't have to write your funnel bars. But yeah, that's what your work paper should look like that. Should look like that. Joe. Yes. Now, the very last question, number 35, is it? 28. Well, I'm on the wrong homework. Number 28 is the very last question. This has been asked about as well. And I did a problem similar to this in your notes yesterday. It was the one we ended on. It was not quite as big as the one in your homework. But what we had to do for this problem, of course, this means what? Divide. So before I divide, I had to figure out what the number was going to be on top. So I did the parentheses, and then I multiplied the 8 to the number that was in parentheses, which was a 7, and we got 56. Then we were able to divide. Okay. Now, if you look at your homework, there's more going on top. There's also a lot going on bottom as well. And so what we're going to do before we divide, you see that division bar, we have to figure out what our dividend is going to be. That's the number you're dividing. And then what our divisor is going to be, the number I'm going to divide by. So I have to really kind of imagine a set of parentheses around the top and bottom, because I have to figure out what those numbers are first before I can do the division. And I know division isn't something you normally do at the end. It's normally adding, subtracting. I can't divide if I don't know what my numbers or what numbers I'm using. So I have to go ahead and I'm going to, whoops. These are hard to funnel down, I'll be honest, just because there's something going on top and bottom. So I'm just going to draw an arrow here for the top and bottom. So let's focus in on the top. Focusing on the top. Frank, on the top, I have division and addition. Which of those takes priority? Good. What's 26 divided by 2? 13. There's the top. Simplified a little bit. Okay. Taylor, on the bottom, I've got an exponent and subtraction. Which of those takes priority? Good. What is 3 squared? That's right. Now that I've got both those simplified a little bit farther down, let's go ahead and take it to the next level. Let's go ahead and do the addition on top, the subtraction on bottom. Natalie Dominguez, what is 13 plus 5? That's right. And back over to Gage. What's 9 minus 3? 6. Now I know what my numerator, my dividend is. I know what my denominator, my divisor is. And so now I can actually do the division. So Andre, what are you going to get for 18 divided by 6? 3 is correct. Nice job. I'm going to go ahead and circle that. My funnel is kind of like a sideways funnel. These are weird problems. You only have one like this one on the homework. So that was a good one to ask about. That was a good one to ask about. If you have more questions over this homework, let me know later. Wait, what were you going to say?
Can you look over
14? I can peek at it real quick. What in number 14 has you perplexed? The whole thing.
Because like I got an answer and I just
Okay, so we'll figure out why it's wrong. We can do this one. Go ahead. This is number 14. Go ahead and write it down. We need to write the original problem down. Also, you want to number it number 14. Parentheses, level 1 priority. However, in these parentheses, I have 2 operations going on, squared and subtraction. So Maddox, which of those takes priority? Do I do the exponents or the subtraction first? That's right. What is 5 squared? 25 means 5 times 5. So now I've got 25 minus 4 in parentheses times 2 minus 18. Still have parentheses because there was 2 operations in the parentheses. So I'm going to do the second one now. Whitney's going to subtract 25 minus 4 for us. 21. So now I have 21 times 2. Frank, are we so good so far? Okay. Hunter, multiplication or subtraction next? Okay, what's 21 times 2? 42. Just double it. 42. So good so far? Why don't you tell me what 42 minus 18 is?
36.
Nope. You just subtracted 8. Subtract 18. Take away another 10, Frank. Yes, I don't know if you did it like this. If you may have just forgotten to borrow and turn that 4 into a 3. So that's going to give us, wait a second. Should be a 4. 24. So you guys are getting 24. You said 26 and I said 36. Susie said the 30. I knew it was, you didn't. Yeah, the subtraction was messed up there. So it should be 24, which means 24. I'm going to put right there. It completes my funnel. It completes my funnel. Any other questions that you have, let's save and you guys can email me or you can come see me later or whatever. This homework is due when? Tomorrow. What else is tomorrow?
Quiz.
A quiz. Quiz tomorrow. Yeah. So here's what I need you to do. This homework's turned in right now. Should be turned in right now for us. Okay. This homework we should have it done. I know it's because it's big ideas assignment. We have until 2:30 to turn it in. However, you take your quiz this period, not at the end of the day. So you're going to want to make sure that 1.3 is done. And then 1.4 is also going to be covered on the quiz. I don't normally do this where I give you a homework tonight and then test it on the quiz the next day. But as I was talking earlier, these are all 6th grade assignments. So because they're 6th grade assignments, you've done them already. And so I'm hoping that with my lesson today, you'll remember these factor trees that you did last year. You'll feel comfortable doing them. There's only 10 questions on the homework tonight, so it shouldn't be something that you spend forever doing. You might even be able to get it done before you walk into your 5th period to take your quiz. But that's the goal. Yes.
Is science in the classroom or is that required? I mean, not required.
I think it's in the auditorium. So let's go to Google Classroom. And you guys are period 5, so let's go to period 5. So back here, if you look back to yesterday, so someone like Navion, for example, that wasn't here yesterday, I've tried to make it as easy as possible. And Taylor, I don't think you were here yesterday for class either. Okay, so I'm trying to make it as easy as possible for those that are quarantined, those that have doctor's appointments, or miss a class period, whatever it is. If you're not here in class, you should be able to see what we're doing each day in Google Classroom. So yesterday, for example, was Wednesday. We did the order of operations lesson. We're just problems for that. Obviously, the homework is the same section on big ideas. And then it tells you what was due that day. Yesterday, we turned in nothing because Monday was an NWEA day. So 2 days later, no homework due. Today's lesson, click on it. You can see we're doing prime factorization. The homework for tonight is going to follow along exactly what we did from big ideas. And then due today is this that we just turned in. So you can actually check this every morning. Even, I don't know what your 1st period class is, but you can check it. It should be posted by first period. And you should be like, oh yeah, turning in 1.2 today. That way you guys know without even coming to my room what we're turning in. If you're at home and you're quarantined, you're like, oh, I need to send him a picture of that work paper so he knows that I've done it. Okay. If I go back one to the order of operations, do you guys notice there's also a video there? So I told you this, if you weren't here yesterday, at the end of the day, the notes that we would have taken in class are already going to be filled in. And there will be a video of the lesson posted. So if you miss something and you're not sure what's going on, you can watch the video of the lesson. Okay, so that at the end of the day today, now the notes you guys are downloading. So if you haven't downloaded them, go ahead and do that to Notability. Give it a second to load when you click on it. Give it a second to load. When it loads and it appears, you'll see another export button right here that you can click on. Remember, we said yesterday that we're going to not attach them to the notes that are already open, but we're going to create a new note. So when you do it, it'll probably say attached to these notes, and you're going to no, create a new one. We want a new note for each section, so they're not putting a really big document together that's hard to navigate through. We just want to each have its own separate document. Yes.
So the 3 bottom rows, when I press it, it says
like a phone number, so it says call. I have no clue.
That's very interesting. Don't call. I don't even know what you're talking, like you're talking about those prime numbers down there?
Yeah.
Yeah, don't do that. No, I don't even know if your iPad has the ability to do that, but I wouldn't even test it because it's probably somebody's phone number. We don't want to, that'd be weird. Spam call. That's why I get so many spam calls. People working on a prime number maze. Just joking. Okay, so they're blank right now, right? If I were to open these notes up after 2:30 today, you're going to notice that they're completed. And there's also a video there of the lesson. Now, I don't want you to just be like, well, I'm just going to goof off in class and down. I want you to follow along with the blank notes and fill them in yourself. That's the goal. Okay. So anyways, we're in section 1.4 right here. And so we're talking about prime numbers today, prime numbers. And we're going to write prime factorizations, but we have to know our prime numbers first. So this is a prime number maze. You are the worm trying to get to the apple, and you can only travel through prime numbers. You can only travel in a upwards, downwards, rightwards, or leftwards. I don't think those are actual words. You can only travel in those directions. You cannot move diagonally. Now, somewhere on the top row of numbers is one prime number. Which one do you think it is, Frank?
12.
Not 12. Maybe we should talk, hang on a second. Maybe we should talk about what a prime number is. A prime number is a number that only has two factors, 1 times itself. It's the only way you can multiply to get it. Every other number is composite. It has 3 or more factors. For example, 5 is prime. The only way I can get 5 is 5 times 1. Can't break it down. 10 is composite because I could do 1 times 10 or I could do 2 times 5. So I have multiple ways, so 10's not prime. Aaron, what do you think our prime number is on the top row?
15.
Not 15. 5 can go into 15. 5 and 3. Natalie? 39? No, that's not prime either. 3 can go into 39. 3 and 9, 39. What do you think it is, Hunter?
37.
It's 37. So what I'm going to do is I'm going to go ahead and make a list for you guys of our prime numbers. Now, what do you think the very first, where should I make this list? I'll make it over here. I'll just write small. What do you think our very first prime number is? The smallest one. What? Not 1. 2. Okay, so 1 doesn't fit in either category. It's not prime, it's not composite. To be prime, you have to have exactly 2 factors, 1 in itself. Well, that itself has to be a different number. 1, the only way you can get it is 1 times 1, it's the same factor, so it only has 1 factor, and it really is the loneliest number. It's not prime. 2 is the very first prime number. 2 is the very first prime number. 3 is prime. Is 4 prime? No, because you can do 1 times 4, but you can also do 2 times 2. In fact, 2 is the only even prime number because every other even number after it, 2 could go into. So I can eliminate all the even numbers. Only 2 works. 2 is the only prime number that's even. Now, to say that though, I'm not telling you that every odd number is prime either. 39 wasn't prime. It's odd, but it's not prime. So not every odd number is prime, but all the other prime numbers will be odd. Okay, so there's a lot of odd composite numbers, but there's quite a few odd prime numbers as well. So we're going to skip all the even numbers now. So not 4. 5. 5 prime? Yes. 7 prime? It is. Yep, 1 times 7 is the only way I can get it. Is 9 prime? No, it's not. I can also do 1 times 9, but also 3 times 3. Okay, so 9's not. What about 11? Yes. Are you making this list as well? It's going to help you on the maze. It's going to help you on the maze. What about 13? 15. 5 can go into it, right? So it's not just 1 and 15, it's 5 and 3 as well. So what about 17? Yep, 17 is prime. 19? It's prime. 21? Why not? 3 times 7, that's right. 21 is not prime. What about 23? 23 is prime. That's right. 25? 5 could go in. You see what I mean? Like not all the odd numbers are prime, but the remaining ones are, right? The remaining primes are odd. They're just not, it's not every single odd number. I'm still skipping some odd numbers. Like 25, I'm skipping. What about 27?
No.
I need to skip 27.
Yeah.
What goes into 27?
No.
9 and 3. 9 and 3. So 27 now. 29, it's prime. 31,
Yes.
it's prime. 33, no, it's not, because 11 and 3, right? 35, 5 goes into that. So no. 37, yes, that's the one you circled right here, right? Didn't you guys circle 37 on your maze? What about 39? Natalie knows. It's not. Yeah, 39 because 3 can go in. 41.
Yes.
41 is prime. Yeah, there's no other factors to it. 43,
Yes.
it is prime. There's no way you can multiply to get it other than 1 and 43. 45,
No.
yeah, 5 goes into it, right? 47, no, it is not prime. Yes, it is.
Yes.
47 is.
Yeah.
47 is prime, but 49, no, because 7 times 7. In fact, 49 we learned earlier this week is called a perfect square, right? 7 squared, so 7 times 7. Okay, that is my list of prime numbers up to 50. That's probably way more than you would ever need to know. In fact, if you just knew that the numbers in the left column over here were prime, you'd be fine on tonight's homework. Okay. Now, the reason I made my list go to 50 is because on this maze you have here, the numbers all go up to 50. So what you need to do is you need to travel your way through this maze, only going up, down, left, right, and circling the prime numbers as you go. It's like a maze, right? So the worm's he's eating his way through the dirt to the apple, I guess. You can go straight down. It's exactly what I would do. I'd go straight down. And remember, you're looking for these prime numbers up here on the top of the page. So I'm not going to go to 20. It's even. So I know 2 goes in. I'm not going to 44. So I got to go over to 7 to the right. And I'm just going to keep going.
Okay, I get it.
Until, there's only one direction that works. Can't go this way. Can't go that way. Got to go to 23. All right. So why don't you guys work on this? I had someone do it in 1 minute. You're already done with it? I'm going to give you 3 minutes. Okay, I'm going to give you 3 minutes to try to progress your way to the apple. I'm going to give you a hint. It's not a direct route. So it's a very much a roundabout way of getting there. Sorry. Jeff, you just got it. We're a little slow getting our notes down. Yeah, we need to probably do that when I say, go ahead and download your notes. You're only progressing through using these prime numbers. Now, the list of prime numbers goes on forever, but I don't need to know all of those. Yes, Aaron.
You can cancel out all of the
Evens
numbers that end with 5.
or 5. Yes, yeah, you're right. Because if it ends in a 0 or 5, 5's going to go into it. In fact, if they're even, you don't want to go that way unless it's a 2. 2 is the only even prime number, and it's also the very first one. So I'm going to try to catch up with you guys as you're working through this. Ouch, just hit a wall. Well, can't go up because 12's not prime. 2 and 6, 3 and 4. So I got to go down. 47. 47's on our list, isn't it? 47's on our list of prime numbers. Okay, keep going. 14. What about 7 and 2? Wouldn't that make 14 composite? You're allowed to go up, down, left, right. No diagonals. No diagonals. Oh. Um, 21, be careful at the 21. 21, 3 and 7 can give you that. So I can't go to 21. I'm going to go over to 23 here. 27. Oh, no, can't go to 27, darn. 27, 3 and 9. So I have to go down to 29, don't I? Whitney, you're done with it? I'll come over there and check it in a second. You finished it too? 31, 7, ouch, hit a wall again. 5, 7, 23, 13, 17. These are all primes. 7, ouch, hit a wall again. 41. Yep. 41 is. Okay. I'll stop right there. You guys catch up and keep going. Not quite there. Let me see what you got, Frank. Yep, good.
Can you check mine?
Yep, give me a second. It's good.
It's not like
Decent. Where are you stuck at?
um
Are you past where I'm at?
yeah.
Okay.
So like a little bit past.
Let me catch. So we went to 31,
Yeah.
11,
Yes.
31, 13,
Yes.
13,
Yes.
41,
Yes. That's where I am.
3,
Oh.
19, 13, 5, ouch, hit another wall. 29, 29, 2, there's 29 again. That's easy. Bunch of 29s there. 37 and 41 are both prime. I can't cut over to 9, by the way, because you know 3 goes into that. So it's not just 1 and 9. So I got to go up to 5, 2, 31, 13,
I did it.
29.
No, I did it.
41. There you go. There it is. Are you, we just finished together? That's cool. That's cool.
That's a worm.
I think it's a worm. It says it's a worm.
It's a workstation.
All right. So now that you know your prime numbers up to 50, we're just going to focus on, like I said, the prime numbers up to probably 13. I bet you'd be, if you just knew that 2, 3, 5, 7, 11, 13 were prime, you'd be fine on tonight's homework. So let's look at what we're actually doing tonight, which isn't just listing prime numbers, but actually finding prime factorization. So the prime factorization of a composite number, the prime factorization of a composite number is a number that's written as a product of its prime factors. Now remember, factors are numbers that multiply together. So what I'm going to do is I'm going to break down a number so that it's broken down into its bunch of primes, that if I multiply the primes together, that would give me the original number. You guys have done this before and you used factor trees to do it. You can use factor trees to help you find the prime factorization. The factor tree is complete when only prime factors appear in the product. This is an example of a prime factor tree. They took the number 60. Now, and this may not be the way you would break it down. This is the way they did. I can tell what they did is they tried to find the smallest prime that went into it, which remember the smallest prime number is 2. And you know 2 goes into even numbers. So they did 2 went into 60 30 times. So they circled 2 because 2's prime. You're done with it. Then they broke 30. What did they break 30 down into? 2 and 15. Could you have done 3 and 10? Yeah, you could have. Could you have done 5 and 6 there? Yeah, you could have. There's more than one way. So they broke 30 into 2 and 15. 2's prime, they circled it. They broke 15 down into 3 and 5, both of which are prime. They circled it and they have their answer. Now, just so you guys know for tomorrow's quiz, the factor tree is the work, not the answer. The factor tree is the work. When you're done, you need to answer them or answer the question and list the prime factors with multiplication symbols between them. And if you can use exponents, you should. So what they did is all those prime numbers they circled, those prime factors, they wrote them as a factorization with multiplication symbols between, and then they notice there's 2 2's. And we can rewrite 2 times 2 as 2 to the power of 2. So that's why we focused on exponents earlier this week, right? Anytime you can use an exponent, I want you to do it. Okay, that's what the instructions are going to say on your quiz tomorrow. Use exponents if possible. Here we can. If there was only a 2, 3, and 5, I couldn't use exponents. So I wouldn't do it there. I only use exponents when I can. Aaron?
I actually found out that it has to be in a specific order. Because when I went on, I typed it in a different order.
No, that's not
I
right.
typed it backwards and it said it was wrong.
Are you sure?
Yes.
Now, it's not wrong. If you would have told me 5 times 3 times 2 squared and you would have given me the numbers out of order, that doesn't matter because it's multiplication. It'd be the same answer. I wonder if you had the squared above the wrong number, or you know what I mean? Like the exponent's above the wrong number, that's an issue. You'll have to show me after class. I want you to show me, okay? You're done with it? So you may just have to let me know what problem is on. We can look at it. Yeah, Frank? Yes. So let's look at 48. Okay, I told you guys there's more than one way you can do your factor tree. So let's look at 48 and list 3 different ways we could do 48 as a prime factorization, starting with the way they did it. Taking out the smallest prime number you can, 2. 2 goes into 48 because 48 is even. And how many times does 2 go into 48? 2 times what? 48?
Oh, 2 times what? Who?
24.
24. There you go.
Oh, yeah.
Now 2 is prime, so we circle it, and then we try to break down 24. Now 24 is also even, so guess what goes into it? 2 again. That's going to be 2 times 12. And guess what? 12 is even. So 2 will go into 12. How many times? 2 times 6. And 6 is even. So we can do 2 times 3. And 3 is also prime. So we're done. We know that we are finally done. Now, all of this is my work. If you put that on your quiz tomorrow, you'll get half a point. Because I actually need your answer too. Your answer is going to say 2 to the what power here, Hunter? Not cubed. There's not 3 of them. There's 4 of them, isn't there? So I'm going to write 2 to the power of 4 because it repeats 4 times. Times, don't forget the time symbol between time or X, whatever you want to use as your time symbol, times 3. And I promise you, Aaron, if you were to write 3 times 2 to the 4th on your quiz tomorrow, I will count it right. Okay, the order doesn't matter to me. Just don't put 3 to the 4th. It's got to be 2 to the 4th, but it can be 3 times 2 to the 4th. You can reverse the order, still the same thing. Yeah, that's one way you could do it. You could also break it down into 4 and 12. I mean, that gives you 48. Your tree would look different then. Now, what does 4 break down into? 2 and 2. Circle both. They're both prime. What's 12 break down into? 6 and 2. Circle the 2. You could also, at that point, you could have said 3 and 4, just so you know. Circle the 2. And what does 6 break down into? 3 and 2, both of which are prime. And guess what? How many 2s did I circle? 4 of them. You get the same answer, even though your tree looks different. So don't be worried if your tree looks different from somebody else's. You should still end up with the same answer. And there's one more way I can show you. Yeah, maybe on.
How did you get 22?
How did I get 22? Where did I put 22 at?
Right into the 4 with that.
Well, that's 2 and 2. 2 and 2 multiplied to give you 4. They're both prime, so we circle both.
Oh.
Another way you could get 48 is by doing 6 times 8. Now, neither of those are prime. So I have to continue breaking them down. I can break 6 down, as you guys just told me, into 3 and 2. But how can I break 8 down? 4 and 2? 2's prime. How can I break 4 down? 2 and 2. Both those are prime. And these trees all look a little bit different, but they all give you the same answer. There are 4 2s. So not 4 to the 2nd power, but 2 to the 4th power times 3. You get the same answer every time. Same answer every time.
This is going to be on a quiz.
This is your quiz tomorrow. Yeah, it's one part of it. There's going to be other exponent problems because we did the whole exponents homework you guys just turned in, right? There's going to be some order of operations questions from the homework on your quiz. And then there'll be some of these from tonight's homework also on your quiz.
Yeah, I wouldn't know if I
What time do we got? 50?
Yeah.
50?
Like 12.
5 minutes? That's enough to do 3 problems. So there's more than one way to make a factor tree, but the prime factorization will always be the same. Your tree could look like that red one that we did here. It could look like the blue one. It could look like the purple one. They're all giving you the same answer. Your prime factorization should still be the same. So that being said, take 2 to 3 minutes. Try the first 2 examples on your own. Try to do the factor tree of 20 and 88. Don't worry about C and D right now. Just do A and B. Try to break down 20 and 88. Take a minute or 2 to do that. Just think about it. And remember, your tree is going to look different from the next person next to you, most likely. Most likely will look different. Don't forget that when you finish your tree, you still need to write your answer underneath of it. Remember the max? That's give you 2 numbers that multiply to give you 20. No, 10 and 2. Okay. 10 and 2 works. You could start there. Did anyone else do 10 and 2 as their 2 numbers? Who did 4 and 5 as their numbers? You could do both ways. You can do both ways. I happen to ask Maddox though, so I'm going to go with his route for this one. But don't erase anything because you're probably still right. Now, one of those is prime. Which one? 2. Yep. They don't have to be prime. It just happened to be one of them was here. Whitney, how do you break down 10? Yeah, and both those are prime, which means we're done. Yeah, means we're done. Now, if you did 4 and 5, you would have gotten 2 and 2 and 5, and you still would have had the same 2 2s that we had. Your 2 2s are my 2 2s. What is the answer? 2, how many 2s do you see? So I'm going to do 2 to the power of 2 times how many 5s you see? So just 5. We don't need to write an exponent there.
Oh.
That's it. That's the answer.
Okay.
This is, again, this is my work, and this is my answer. Sorry, my handwriting's not super good right there. That's my answer. Now, what about 88? Taylor, how did you break down 88?
11 and 8.
11 and 8. That's what I would have done. Did anyone do 2 and 44? 4 and 22? Nobody on that one. Nobody's riding that train.
I did 2 and 44.
2 and 44. If you do 11 and 8, by the way, 11 is prime. And then 8 breaks down into 2 and 4. And 4 breaks down into 2 and 2. And our work's done. We just have to write our answer.
I just always try to break it in half. So it'd be
2 to the power of 3 times 11. That's right. Yeah. Make sure you use exponents if you can. Don't write out 2 times 2 times 2 times 11. Why would you want to do that anyways? It's easier to write 2 to the third. Yeah. If you did, some of you said you did 2 and 44, then I'm guessing you probably broke 44 down into 2 and 22. And then you broke 22 down into 2 and 11, and you got your 3 2s, and you got the 11. Yep.
Wait,
Here?
yeah.
Because 2 times 5 gives me 10.
Oh.
Remember, we're multiplying them together, not adding them.
So instead of 5, I should put 2.
2 and 5, that's right. Yep, you're breaking them down. Remember, it's a prime factorization, and that word factor means you're multiplying, just like when you hear product. Ooh, that's the answer to a multiplication problem, right?
Yeah.
Okay. One more. 90 is not too difficult to break down. Oh, come on. It ends in 0. It ends in 0.
Is it
10 times 9, or 45 and 2, or 30 and 3. So you can do 30 and 3 as well, right? Okay. How could I break down 10? Frank? 2 and 5, both of which are prime. Joe, how can I break 9 down?
Wait, I forgot. Me too.
3 and 3.
That's right. Both of which are prime. So I have, oh, this is a very nice looking factor tree, right? It's very symmetrical. Looks like a Christmas tree almost. So it's not the 2 that's repeating here. It's actually the 3. So 2 times 3 to the power of 2 times, there's still a 5. That's my answer. And I don't care if you put 3 to the power of 2 times 5 and 2. The order to me doesn't matter. As long as you've got a 2, you've got a 3 squared, and you've got a 5, and you got time signs between them. That's it. The order does not matter. Yes.
With the 9, you can actually just skip it. Right now, so.
9's not prime though. Because I can't do that with 10. I can't skip 10 because I gotta break it down with 2 and 5. You see what I'm saying? Like if
Yeah.
you're done when you got all the primes at the end of your branches. Okay. Like imagine the little circles being ornaments and every branch has to have an ornament on it. So you know you're done. Like, you know, so what? This branch right here doesn't have an ornament. Well, that's not a branch. Look at the end of it. Yeah, there's one right there. We'll do example D tomorrow. That might be a good way to get our heads working again before we take our quiz. All right.
Probably.
This is tons of examples for you guys to get started on your 10-question homework assignment. I will see you tomorrow. You're heading to 6th period. Have a great day. That's right. Have a great day.
Have a good day. Have a great day.
Have a great day. Thanks, Taylor. Appreciate it. You really